Hi, I'm Sean Reagan. I'm technical editor for Make Magazine. If you've ever built a robot or other project that uses a small DC motor, you may have run into a speed problem. Off the shelf, most of them just run too fast for so-called direct drive applications. That's where you connect the load that you want to turn directly to the motor shaft. Sometimes you can use gears or pulleys or some other sort of mechanical drivetrain to slow down the motor output and solve your problem, and sometimes you can't. In those situations, you'll need an electronic speed controller, which is where this comes in. We call it the dial-a-speed. It can be used with almost any small DC motor or brushless fan that will run at 12 volts or less. The dial-a-speed uses a potentiometer, a 555 timer, and a MOSFET to switch the motor's power supply on and off at a set rate. The total power delivered in a given time is determined by the potentiometer setting. My design is based on a circuit posted by Rick Bickle of the Dallas Personal Robotics Group with a few minor modifications. You'll need to pick up the following parts to make this project, all of which can be found at your local Radio Shack. You'll also need these basic tools. Let's get started with the build. We'll start by cutting down the potentiometer shaft. Use a hacksaw to make the cut, then a file to smooth the edges. Next, twist and solder a pair of diodes and a small length of wire together to make a Y-shaped junction. Note the orientation of the silver stripes. Now you can solder the free ends of the diodes to the potentiometer's outer terminals and another length of wire to the center terminal. Apply heat shrink tubing to make sure the diodes don't short against the center terminal. The transistor that switches the motor current may get a bit hot when running, so we'll attach a heatsink to keep it cool. First, bend the 3 MOSFET legs up toward the transistor. Cut a piece of double-stick foam tape to fit the front surface of the body and stick it in place. Strip the end of a length of wire, grip on the uninsulated ring tongue lug, and solder it in place. Next, attach the MOSFET and the ring tongue lug to the heatsink with a machine screw. Now we'll start wiring up the circuit board. Start by soldering all 8 legs of the 555 timer into the PCB and attaching a piece of foam tape to the back. Now, we can solder in the PC board terminals, one above and one below the 555. Next, we'll add a diode right below the 555 timer, making sure that the silver stripe on the diode body is closest to pin 4. This helps control the counter-electromotive force that occurs when motors are switched off. The next 2 components are ceramic capacitors. The first is soldered between pin 5 and ground, and the second one is soldered between pins 2 and 6 and ground. Next, we'll add the electrolytic filter capacitor. It's soldered to the board laying down on its side with its positive lead connected to pin 8 and its negative lead to pin 5. Connect the wire from the potentiometer terminal to pin 3 on the 555 timer and the wire from the diode junction to pin 2. Run the stripped leads in from the component side of the board, then bend and solder them on the copper side. Now we can add the MOSFET. First, remove the protective layer of foam tape from the MOSFET and the 555 timer. It's important that the MOSFET is aligned perfectly. The first lead should be aligned next to the 555 timer's pin 7, the second next to pin 6, and the third next to pin 5. Once aligned, carefully guide the leads through the PCB holes and push the MOSFET in until the 2 pieces of tape stick together. Now bend the flange lead down and solder it in place. Then bend the transistor's first lead away from the IC, solder it in place, and reflow the solder at pin number 7. Solder the second transistor lead and cut off any excess metal. Finally, solder the third lead into place and reflow the solder to connect it to the adjacent capacitor lead. We're almost done. There's just 4 more solder side connections. First, install a pull-up resistor between pin 7 and the top left terminal pin. Next, install a red power jumper between the VCC terminal pin and the bottom right terminal pin. Then, install a jumper between the MOSFET flange lead and the bottom left terminal pin. Finally, install a jumper wire between the top right terminal pin and the MOSFET's third lead. Remember, you can refer to the project page for detailed instructions on how all the components work, electrical schematics, and our troubleshooting guide. Well, that's it. The circuit is now complete. Let's check it out. The potential applications for this circuit are many and varied. You could use it to build an adjustable magnetic stir plate for your laboratory, or an adjustable fan or fluid pump. You can even use it for non-motor applications like dimming incandescent or solid-state lighting, or for whatever else you can imagine. I'm going to use mine to upgrade my original optical tremolo box for better low-speed control, What will you do with yours? Please let us know in the comments on the project page.